Go.
Hello, my name is Carlos Andrade.
And I'm Cindy Ventura.
Today we're going to be talking about Lewis structures, which are diagrams that show the bonding between molecules and the lone pairs that may exist. And we are also going to be talking about the chemical formulas.
We're also going to be talking about the molecular shapes and their angles and building 3D models of them. Our first example is selenium dichloride. The chemical formula for selenium dichloride is SeCl2. There's 2 chloride because of the prefix di. Next, we have to count the number of electrons in order to make the Lewis structure. In order to do that, we need our periodic table. You can see that there's 6 electrons in selenium plus 7 electrons in chlorine times 2. This gives us 20 electrons. Now we can draw our Lewis structure. Selenium is going to be our central atom because there's only one of them. And it's going to be single bonded with chlorine on either side. The lines count for a single bond, which equals 2 electrons. That's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. There's 2 lone pairs in this Lewis structure. So the name of this Lewis structure is a tetrahedral bent. And the angle for this structure is less than 109.5. Next, we have to do our 3D model. So we're going to use these pieces to make it. We're going to have 2 single bonds, and we're going to have 2 lone pairs. Ta-da! Our second example is carbon tetrabromide. The chemical formula for carbon tetrabromide is CBr4. There's 4 bromide because of the prefix tetra. Next, we have to count the electrons in this chemical formula in order to draw our Lewis structure. So we have to look at the periodic table and see that carbon has 4 electrons and bromide has 7 electrons, and you multiply that by 4. So that gives us 32 electrons. Carbon is going to be our central atom, and it's going to be single bonded with bromide. Four times. And remember, a line equals a single bond, which equals 2 electrons. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. This Lewis structure's name is a tetrahedral with an angle of 109.5. Next, we're going to do the 3D model, and we're going to get our pieces here. And it has 4 single bonds and 4 bromides. And you're done.
Our third example is boron tribromide. The chemical formula for boron tribromide is BR3. We know there's 3 bromides because of the prefix tri. The Lewis structure for boron tribromide is going to be, but don't forget to count your electrons. So we have boron, which is 3, and you have bromide, which is 7, and since you have 3 of them, it's 21 plus 3, that's 24. So we know that boron is going to be our central atom, and it's going to be surrounded by bromide. This represents a single bond. A single bond represents 2 electrons. Okay, so we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So there you go. And so we look at our little helper right here, and we know that the shape is going to be trigonal planar. And we know that the angle for that is 120 degrees. So to draw it, the 3D model would be, here's your boron, here's a single bond, and here your bromide. Wait, trouble. Wait, got it. There you go. Trigonal planar. Our fourth and final example is nitrogen trifluoride. Our chemical formula for that is NF3. We know it's 3 because of the prefix tri. So to get ready for Lewis structure, we have to count how many electrons we have. Nitrogen has 5, plus fluoride, which has 7, and since there's 3 of them, it's going to be 21 plus 5, which is 26. Okay, so we know that nitrogen is going to be our central atom. We have it surrounded by fluoride, right? So this once again represents a single bond, which represents 2 electrons. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and 26. What we have right here is one lone pair. So the shape for this is going to be trigonal pyramidal. And the angle for that is going to be less than 109.5. Okay, now to make the 3D model of it, this is going to be our nitrogen. This represents our single bonds. So we have 1, 2, 3, and these represent our fluoride. So there's 1, 2, and 3. And this, my friends, represents one lone pair. So there you go. We have trigonal pyramidal, nitrogen trifluoride.